So in this video, I want to talk about the derivative function. If you remember, the derivative is defined to be the rate of change. It's also the slope of the tangent line. So I want to give you a geometric argument onto why that particular formula you see is correct. So let me start by drawing an arbitrary graph. I'll draw a vertical axis and a horizontal axis, and I'll put some arbitrary curve in here. I will call this curve f of x. In fact, it is y equals f of x. I'm going to pick a point on here. And my goal is to figure out the slope of that tangent line. So that's my goal. Slope of the tangent line. That's what I would like to do. Well, what I want to do is I'm going to introduce another point in here. And this is going to be my helper. I am going to use these 2 points to compute the slope of the tangent line. Or at least to give you the idea of why the formula you see is correct. I'm going to give this point a name, or the x-coordinate a name. I'll just call it x. Now this particular point, what I can do is I can give it a name, or I can say the distance between these two is h. So what does that mean? That makes this particular point x plus h. Now remember, a derivative is a rate of change. So I am going to compute the rate of change of this particular line. In other words, I want to figure out the slope of this line. So this purple line. So what is the slope of the purple line? Well, what I do know, it is equal to the change in the y value divided by the change in the x values. Well, this particular point, that has coordinates x, comma f of x. This particular point, this particular point has the coordinates x plus h, comma f of x plus h. So this point here has an x coordinate of x plus h. In other words, the input is x plus h. And the output is f of x plus h. This point over here has an input of x and an output of f of x. So how am I going to use that? Well, I'm going to take the difference of the y's. F of x plus h, there's that y value, minus that y value over the corresponding x values, which this one is x plus h, minus this one, which is x. If I do a little simplification, I wind up getting f of x plus h minus f of x. Well, I didn't simplify the numerator. I really can't. But what happens to the x's here? I wind up just getting an a. So this is the slope of the purple line, the secant line. What about my tangent line? What about this one? Well, the idea is to get h, to get this point very, very small. It's to change h and make it equal to 0. Well, can't make it equal to 0 because I can't divide by 0. So that's where the idea of the tangent, the limit comes into play. So the slope of the tangent line is the limit of this expression as h goes to 0. And That is why the formula that you see is the slope of a tangent line for a given curve. But be very careful. Not every limit exists. So you need to take that into consideration when you're actually computing these limits. I hope this video was helpful. Have a great day. Bye.